Imagine a world where the tiny, hyper-efficient chip architecture powering your smartwatch is essentially the exact same architecture powering massive skyscraper-sized AI data centers.
I mean, it sounds completely counterintuitive, right?
It really does.
hmm
But as we look at the latest industry shifts, that is exactly what's happening. Welcome to the deep dive, everyone.
Thanks for having me back.
Yeah, of course. Today, we are exploring the Q3 fiscal 2026 earnings of a company most people associate with just, well, one thing, the smartphone in your pocket, Qualcomm.
Right, the classic Snapdragon chips.
Exactly. But what the sources reveal is that this tech giant is undergoing a massive, a really rapid mutation.
Oh, absolutely. It's not the same company it was 5 years ago.
No, not at all. So our mission today is clear. We're going to unpack these Q3 financials, decode the current supply chain struggles that are, causing some serious short-term pain, and then explore their incredibly aggressive $40 billion pivot into the future.
Yeah, cars, smart glasses, AI data centers, the works.
Right. But before we get into all that, I need to put this out there for you guys listening. All the information and analysis we discuss here is just to help everyone better understand the market and is not investment advice.
Very true.
Yeah. Investing carries risks, so please make sure to do your homework or consult a professional financial advisor before entering the market.
Essential disclaimer for sure.
Always. All right, with that out of the way, I have to say earnings calls are usually pretty dry, but looking through this material, it felt entirely different.
It really is a fascinating document. I mean, usually an earnings call is just a recitation of past performance, right? Like a look in the rearview mirror.
Yeah, just spreadsheets and percentages.
Exactly. But reading through this specific fiscal Q3 presentation, it genuinely reads less like a quarterly recap and more like a strategic roadmap for the next decade of computing.
Wow.
Yeah, and the central theme connecting everything we're going to discuss today is power efficiency.
Yeah.
Qualcomm is basically fighting a war on two fronts right now.
Okay, let's unpack this, because before we can talk about where Qualcomm is going, we kind of have to look at the pressure cooker they're sitting in right now.
Oh, definitely. The mobile market is tough.
Right. I was looking at the headline numbers for Q3, and it wasn't a simple story of success or failure. The vibe was, well, complicated. Total revenue hit $9.95 billion, which actually beat the analyst estimate.
Which you'd think would be great news.
Yeah, but then the adjusted earnings per share, or EPS, came in at $2.21, missing the $2.23 estimate. And then their guidance for the current quarter, Q4, it actually spooked the market.
It really did.
They're expecting $9.7 to $10.5 billion in revenue and an EPS falling short of what analysts wanted. So if they are selling enough chips to beat revenue estimates, why is the profit side of the equation looking so soft?
Well, you're picking up on the exact friction point the market reacted to. The culprit here is the global supply chain. In the presentation, management points to severe, what they call cyclical headwinds. Specifically, they're facing a broad-based, industry-wide increase in input costs across, almost every single step of manufacturing a chip.
Wow, every step.
Pretty much. We're talking about wafer fabrication, advanced packaging, assembly, and especially memory components. Every part of the recipe suddenly just costs more.
Wait, before we go further, let's break some of it down for the listener. When you say wafer fabrication and advanced packaging, what exactly is getting more expensive in physical terms?
Good question. Let's look at it sequentially. Wafer fabrication is the process of literally baking the silicon cake, right?
Making the actual chip.
Yeah, using extreme ultraviolet light to etch billions of microscopic circuits onto a disk of raw silicon. The chemicals, the energy, the foundry time for that process, they've all seen massive price spikes.
Yikes.
Right. And then you have advanced packaging. Instead of laying chips flat next to each other on a circuit board, which, takes up space.
Right, phones are getting smaller, or trying to.
Exactly. So the industry is now stacking them vertically in 3 dimensions to improve speed and save space. That 3D stacking requires incredibly precise, specialized machinery.
And I'm guessing that machinery isn't cheap?
It's not, and there's a massive bottleneck in the industry right now just to get access to it.
So to use an analogy, it's like you're a high-end electric vehicle manufacturer. You have plenty of customers who want to buy your cars, so your top-line revenue looks great.
Right.
But suddenly, the cost of raw lithium for the battery spikes, and the specialized robots you use to assemble the chassis become twice as expensive to rent.
That's a great way to look at it.
You're still selling the car for the same price, but your actual profit per vehicle is just vanishing.
That captures the dynamic perfectly. The revenue is there, but the cost to deliver the product is just eating the margins. And unfortunately for Qualcomm, this squeeze is hitting their biggest historical moneymaker the hardest.
The handset business.
Yeah, smartphones. Handset chip sales dropped 20% year over year, down to $5.1 billion. They noted this reflects a bottoming out of the China smartphone market.
20%, that is not a small flesh wound.
No, it's driving a massive projected EPS impact of greater than $1.50 for fiscal 2026.
That is a staggering hit to the bottom line. And, digging into the sources, it's not just the broad Android market in China causing friction. There's a very specific fruit company stepping away, right?
Right. I mean, I would actually frame it as a long-expected departure finally accelerating. Qualcomm noted that their modem share for the upcoming Apple iPhone launch is stepping down materially lower than their previous estimate of 20%.
Because Apple wants to do it themselves.
Exactly. Apple's been trying to build its own modems for years to stop paying Qualcomm licensing fees. So you have rising manufacturing costs on one side and a shrinking piece of the premium smartphone pie on the other.
Which brings us to how a massive tech giant actually survives a scenario like this. CEO Cristiano Amon was incredibly blunt about their short-term fix. He essentially said, cost went up, prices are going to go up.
Yeah, he didn't sugarcoat it.
Not at all. They are taking concrete measures, specifically raising prices across the board for their chips, starting on September 1st. They are doing this to protect their gross margins.
And just to clarify the financial mechanics here for the listeners, gross margin is the percentage of revenue remaining after you subtract the direct costs of physically producing the goods.
Okay, so the basic profit before other expenses.
Right. If it costs you $40 to make a chip and you sell it for $100, your gross margin is 60%. But out of that $60, you still have to pay your engineers, your marketing team, and fund your research laboratories.
Which aren't cheap for a tech giant.
Exactly. Amon views this current margin squeeze as a temporary phenomenon. By hiking prices now, they protect that gross margin so they can continue to fund their future research while waiting for the memory market to stabilize.
But wait, this raises a massive red flag for me. If we look closely at the source material, Amon himself admitted that consumers are currently holding on to last year's phones much longer because of affordability issues.
Yeah, upgrade cycles are definitely stretching out.
Right. The memory price increases have already made manufacturing phones more expensive. So if Qualcomm raises the price of the processor chips on September 1st, won't the smartphone brands just pass that cost directly on to the consumer?
Almost certainly.
And won't making a premium Android phone even more expensive just destroy whatever demand is left in the market?
You've hit on the absolute core tension of their entire Q3 strategy. It is an incredibly delicate balancing act, and there are no easy answers here.
It sounds super risky.
It is. You're absolutely right that raising prices risks suppressing demand in an already contracted market. However, from Qualcomm's perspective, they have to protect that gross margin, because if they don't have cash flow, they can't fund their massive pivot into new technologies.
So it's a trade-off.
Yeah, it's a calculated risk. They're betting that the premium device market is resilient enough, or perhaps the consumers will accept higher retail prices if the new AI features on the phones justify the cost.
Here's where it gets really interesting, though. Because they're getting squeezed so hard in smartphones, they aren't just sitting around crossing their fingers for the phone market to bounce back.
Right, they're moving fast.
They're aggressively accelerating their diversification strategy. If phones are stalling, what is accelerating? Cars. The Q3 numbers show automotive sales hit $1.59 billion. That is a massive 61% year-over-year growth.
What's fascinating here isn't just the sheer percentage, but the historical consistency of it. This marks 23 consecutive quarters of double-digit year-over-year revenue growth in their automotive sector.
Wait, 23 quarters?
Yeah. That kind of sustained multi-year growth completely changes the narrative of the company. It proves this isn't a fluke. It's a structural shift in their business model.
And they keep raising their own targets because of it. They originally targeted a $6 billion annualized run rate exiting fiscal 2026. Now they've bumped that up to $7 billion.
And aiming for $10 billion by fiscal 2029.
Right. So how exactly is a company known for phone chips taking over the car industry so fast?
It comes down to a metric the industry calls content per vehicle. A decade ago, a car might have a few basic microcontrollers for the radio, the power windows, or engine timing.
Maybe $50 worth of silicon total.
Exactly. But Qualcomm is pushing what they call the Snapdragon Digital Chassis. This is a comprehensive cloud-connected hardware and software platform handling telematics, 5G connectivity, digital cockpits, and advanced driver assistance systems, or ADS.
I love looking at it this way. If you are listening right now and wondering why your new car's dashboard suddenly feels like a giant high-speed iPad, this is why.
Yeah, but it's all connected.
Modern cars are no longer just mechanical engines with wheels attached. They're basically massive computers that you happen to sit inside. And Qualcomm looked at that transition and said, we don't want to make the wheels, and we don't want to make the battery. We want to be the brain.
And this ties perfectly back to our narrative thread of power efficiency.
Yeah.
Electric vehicles suffer from range anxiety. Every watt of battery power used to run the navigation screen or the self-driving cameras is a watt that can't be used to turn the wheels.
Oh, that makes so much sense.
Because Qualcomm spent 20 years learning how to do intensive computing on a tiny phone battery without melting your pocket, they're uniquely positioned to provide highly efficient brains for electric vehicles.
Right, keeping the power consumption low.
Exactly. It's why they just secured a massive new chip supply deal with BMW for their next-generation digital cockpits right in the middle of this quarter.
That is wild. And it's not just cars either. We should briefly note their Internet of Things, or IoT, revenue. That division, which covers industrial networking, robotics, and low-power edge devices, also grew 9% to $1.83 billion.
Yeah, it all points to a steady, relentless escape from the handset market.
Which is critical because Qualcomm has set a staggering new target, $40 billion in non-handset revenue by 2029. Dominating cars and robotics is incredibly lucrative, but to hit $40 billion in 5 years, automotive alone won't get you there.
No, it won't. You need a bigger fish.
Right. To hit $40 billion, you have to go after the ultimate prize in tech right now. You have to go after the AI data center infrastructure.
This is where the mutation of Qualcomm becomes most aggressive. They're targeting $15 billion in data center revenue alone by 2029.
$15 billion.
Yes. They're attempting to burst into a market heavily dominated by incumbents, and they're bringing serious hardware to the fight.
The sources detail the rollout of their new Qualcomm Dragonfly portfolio. We are talking about the C1000 CPU and the AI300 inference accelerator. And they didn't just announce the hardware, right?
No, they had a major partner lined up.
They announced a massive multi-generation agreement with Meta to power their growing data center compute footprint starting in the second half of 2028. These custom chips are boasting over 5 gigahertz clock speeds and chiplet designs with over 250 cores.
It's some serious engineering.
Okay, pause. I need to play translator here for a second. What is a chiplet design, and why does Meta need a chip with 250 cores?
Let's tackle the chiplet design first. Historically, a processor was one giant monolithic piece of silicon. But as chips get bigger, manufacturing one flawless giant piece becomes incredibly difficult and expensive. Like one tiny dust particle ruins the whole thing.
Oh, wow. So what's the alternative?
A chiplet design is basically like building with Lego blocks. You manufacture smaller, specialized pieces of silicon, one for memory, one for processing, one for networking, and you stitch them together seamlessly.
That sounds way more efficient.
It is. It drastically improves manufacturing yield and lowers costs. As for the 250 cores, that's all about parallel processing. AI doesn't just do one math problem really fast. It does millions of smaller math problems simultaneously.
Oh.
Having 250 cores allows the chip to process massive amounts of AI data at the exact same time.
But why is Qualcomm jumping into the data center now? The sources mention we are moving into the agentic AI era. To me, agentic AI sounds like AI that actually does chores for you instead of just chatting.
It's a great way to put it.
But how does that change the physical hardware requirements in a building full of servers?
Your definition is spot on. Most AI today is conversational. You ask a question, it retrieves text. Agentic AI takes actions on your behalf. It navigates complex software, dynamically books flights, organizes your schedule.
Which takes a lot more brain power.
Yes. This requires continuous real-time reasoning, which creates a massive architectural bottleneck in current data centers known as the memory wall.
The memory wall. I like to picture that like a world-class, lightning-fast chef in a massive commercial kitchen. The chef is the processor, right?
The core brain.
But the chef's pantry, where all the ingredients or the memory are stored, is all the way down the hall. The chef can chop vegetables in 2 seconds, but he has to stand around doing nothing, waiting for a slow waiter to walk down the hall, grab a single onion, and walk it back.
That is a phenomenal way to visualize it.
The bottleneck isn't the chef's speed, it's the physical distance to the pantry and the speed of the waiter.
Exactly. And in a data center, every trip down that hall costs electrical energy. In the AI industry, they measure this efficiency as energy per token. Basically, how much electricity it takes to generate one word of AI output.
So lower is better.
Much better. Because of the memory wall, massive data centers are hitting the physical limits of the local power grids. Qualcomm's solution to this is what they call high bandwidth compute, or HPC.
So using the kitchen analogy, HPC is basically taking the pantry and building it directly inside the kitchen, right next to the chef's cutting board.
Precisely. High bandwidth compute physically integrates the processing cores directly with high-density memory. It eliminates the long walk down the hall.
Wow.
Yeah, it breaks the memory wall, drastically lowering the energy per token and improving performance per watt. And this brings us right back to our core narrative. A mobile company, which spent decades obsessing over how to make a phone battery last all day, is now uniquely positioned to solve the biggest power consumption problem facing global AI data centers.
But hardware is only half the battle. To truly compete in the data center space, especially in AI, you need the software ecosystem to run it. And the current AI software landscape is highly dominated by closed systems.
Very true.
Developers get locked into using one specific brand of hardware because they are forced to use that brand's proprietary software tools. If you try to switch hardware, you basically have to rewrite all your code.
And if we connect this to the bigger picture, this is exactly why Qualcomm's software strategy is just as aggressive as their silicon.
Oh, definitely.
During this quarter, they completed the acquisition of a very buzzy software company called Modular Inc. And they announced a massive expansion of their partnership with Hugging Face, which is essentially the central hub for AI models, aiming to reach 16 million developers.
But hold on, let me push back here. Why would Qualcomm, a company that makes its money selling physical hardware, actively champion an open software ecosystem? Modular's entire pitch is that it decouples AI software from the underlying hardware, making it hardware agnostic.
Right?
Doesn't that mean developers could use Qualcomm's software tools to program chips made by their competitors? Aren't they just giving away the walled garden?
I'd look at it from a slightly different angle.
Yeah.
Walled gardens are incredibly profitable, but they only work if you are the incumbent who already owns the market.
Okay.
Qualcomm is the challenger in the data center space.
Ah.
They know developers hate being locked into proprietary ecosystems. By building a frictionless, open environment where a developer can build an agentic AI model once and run it on any hardware, they eliminate the switching costs.
Oh, I see.
Yeah. Qualcomm is making a massive, confident bet. They believe their hardware is so vastly superior in power efficiency that if they level the software playing field, customers like Meta will naturally choose the Snapdragon architecture on pure merit.
That makes a lot of sense. They're trying to commoditize the software layer to force a competition based purely on hardware efficiency.
Exactly.
And it's not just the data center either. The sources outline how they want this open ecosystem to span the entire compute continuum. So you could start a workload in a massive metadata center running a Dragonfly C1000 and then seamlessly push that workload all the way down to a personal device on the edge. Like, say, a pair of smart glasses.
Exactly. The sources highlight the Snapdragon Start program, which is a complete reference platform for intelligent eyewear. Yeah. We are talking about a market of 600 million global eyewear units shipped every year.
That's huge.
It is. Qualcomm envisions a world where an open software layer orchestrates AI tasks seamlessly, from the data center to the PC to the smartphone, right down to the smart glasses on your face.
Yeah. So what does this all mean? We have covered a massive amount of ground today.
We really have. If we synthesize everything from the Q3 earnings, the picture is one of painful but necessary transformation.
Yeah, growing pains.
Exactly. Qualcomm is currently enduring severe cyclical headwinds. The memory crunch and rising input costs are deeply squeezing their traditional smartphone business, forcing them to raise prices and issue conservative financial guidance.
The short-term pain.
Right. But rather than retreating, they're using this pressure as a catalyst. They are leveraging their unmatched expertise in power-efficient computing to drive a $40 billion diversification strategy. They're already dominating the automotive sector, transforming cars into rolling computers, and now they're launching a highly ambitious open-source assault on the AI data center infrastructure market.
And this matters to you, listening right now. Because whether you are buying a new EV, deciding if you want to pay a premium for the latest smartphone, or just wondering how the AI chatbots you use every day actually function behind the scenes, the physical silicon brains powering your daily life are shifting dramatically.
Completely.
The company that built the mobile revolution is now aggressively trying to build the infrastructure for the AI revolution.
It is a profound structural pivot. And this raises an important question, something we should all be keeping a close eye on as this plays out.
What's that?
If Qualcomm successfully executes this roadmap, if they transition from being just the king of the smartphone to becoming the open-source, power-efficient brain of everything from your car to Meta's massive data centers, how will that fundamentally shift the balance of power in the global AI wars over the next decade?
That is a fascinating thought to leave on. The battle for the future of artificial intelligence isn't just a software war. It's being fought on the microscopic silicon level, and the rules of the game are being completely rewritten as we speak. Thanks so much for joining us on this deep dive. We will catch you next time.